Good morning, students. Let us continue the discussion. So now continue the problems on the solutions of linear equations by using matrix forms. Yesterday we discussed in one of the problems in 3x3 determinants. So today is also continuing the same types of problems. Now first we'll consider the linear equation 2x plus 3y plus 3z equal to 5, x minus 2y plus z is equal to minus 4, 3x minus y minus 2z is equal to 3. Now let us consider the elements of the matrix A. Now elements can be arranged in their column wise if their coefficients of x, y and z. If their coefficient of x are along represented in the first column, coefficients of y are along in the second column and z are along in the third column. Therefore, the coefficient of x are 2, 1, 3 are the elements of the first column. Coefficient of y 3, minus 2, minus 1. 3, minus 2, minus 1 are the elements of second column, and coefficient of z 3, 1, minus 2 are represented in the third column. Now first we will find determinant of A. So 2 of directly it's get multiplied. 2 of elements of first row and first columns are get neglected. The remainings are get using their cross multiplication. Minus 2 into minus 2 is 4. Minus 1 into minus 1 is plus 1. Second element is multiplied by minus 3. Minus 3 of. So second element is an element of first row, second column, and these are get neglected. Remainings are get cross multiply. Minus 2, minus 3 plus third element 3. 3 is an element of first row, third column, and those are get neglected. Remainings are get cross multiply. Minus 1 plus 6. Then 4 plus 1 is 5. 5 into 2, 10. Minus 2 minus 3 is minus 5. Minus into minus is plus. 5 into 3 is 15. Minus 1 plus 6 is 5. Again 5 into 3 is 15. 15 plus 15, 30. 30 plus 10 is 40. And it's again not equal to 0. Therefore, the given matrix A is one of the non-singular matrices. Then next we'll find adjoints. A11. So A11 it's multiplied by plus, and it's an elements of first row, first column. These are get neglected. Remainings are get cross multiply. 4 plus 1. It will be equal to 5. Then A12 it's multiplied by minus, and it's an elements of first row, second column, and these are get neglected. Remaining is minus 2, minus 3. Minus 2 minus 3 is minus 5. Minus into minus is plus 5. Then A13 it's multiplied by plus, and it's an elements of first row, third column, and these are get neglected. Remainings are minus 1 plus 6. Minus 1 plus 6, 5. 5 into plus is plus 5. Next one is A21. A21 is multiplied by minus, and it's an elements of second row, first column, and these are get neglected. Remainings are get cross multiply. Minus 6 plus 3. So minus 6 plus 3 is minus 3. Minus into minus is plus 3. Then A22. A22 are multiplied by plus, and it's an elements of second row, second column, and these are get neglected. Remainings are minus 4, minus 9. So minus 4 minus 9 is minus 13. Into plus is also minus 13. Then A23 it's multiplied by minus, and it's an elements of second row, third column, and these are get neglected. Remaining are get multiply. 2 into minus 1 is minus 2. Minus 3 into 3 is 9. So minus 2 minus 9 is minus 11. Minus into minus is plus 11. Then third row A31. A31 is multiplied by plus, and it's an elements of third row, first column, and these are get neglected. Remainings are get cross multiply. 3 plus 3 2s are 6. 3 into 1 is 3. Right diagonal is minus 6. Minus into minus is plus 6. Then 3 plus 6 is 9. A32, it's multiplied by minus. And it's an elements of third row, second column. And these are get neglected. Remaining are 2 minus 3. So 2 minus 3 is minus 1. Minus into minus is plus 1. Next last element is A33. A33 is multiplied by plus, and which is an elements of third row, third column. These are get neglected. Remaining are get cross multiply. Minus 4 minus 3. It will be equal to minus 7. Therefore, adjoint of A is nothing but transpose of the cofactor. Now elements of the first row. What are the cofactor elements of the first row? 5, 5, 5. And elements of the second row. 3 minus 13, 11. 3 minus 13, 11. And elements of the third row, 9, 1, minus 7. After transpose of that matrix, elements are 5, 3, 9, 5, minus 13, 1, 5, 11, minus 7. These are will be called as adjoint of A. So after then, by using the formula for inverse. Now A inverse is nothing but 1 over adjoint of determinant of A into adjoint of A. A inverse is defined by 1 over determinant of A into adjoint of A. So what about the value for determinant of A? Is 40. That is 1 divided by 40 into adjoint is 5, 3, 9, 5, minus 13, 1, 5, 11, minus 7. So after then, by using the condition of solutions of the equation. Now x is nothing but A inverse into B. Consider x is equal to A inverse into B. Now elements of A inverse are 1 divided by 40 into adjoint is 5, 3, 9, 5 minus 13, 1, 5, 11, minus 7 into elements of B. So B are represented for some constants on their given equation, that is 5 minus 4 3. So constants are nothing but 5 minus 4 3. So after then we will get multiply 1 divided by 40 of elements of first row, first column. 5 into 5 is 25, plus into minus is minus, 5 if 3 into 4 is 12, plus 9 into 3 is 27. Then elements of second row. 5 into 5, 25, minus into minus is plus, 13 into 4, 42, plus 1 into 3. Then again first row, third row, first column. 5 into 5 is 25, 11 into minus 4 is minus 44, minus 7 into 3 is 21. That is 1 divided by 40 of 25 minus 12, 25 minus 12 plus 27 equal to 40. 25 plus 40 plus 3, 68. 25 minus 44 minus 21 is minus 40. Sorry, we'll make it a correction. 13 into 4 is 52. So 52 plus 32 is 80. So we'll get multiplied by 40. 40 by 40 is 1. 80 by 40 is 2. 40 minus 40 by 40 is minus 1. So these are the values of capital X. But capital X is denoted by elements of variables x, y and then z. Therefore, we will comparing the corresponding elements of the two matrices. Then the values of x is equal to 1, y is equal to 2 and z is equal to minus 1. Now these are will be called as solutions of that equations. Similarly, we will be continuing the next problems. We'll see. Next one, 2x plus y plus z equal to 1, x minus 2y minus z is equal to 3 by 2, 3y minus 5z is equal to 9. Let elements of A. So if all the coefficients of x, y, z in all the three equations are represented in the elements of the first column. Now what are the coefficient of x? 2, 1, but in the third equation is nothing but 0, because the third equations does not contain their coefficients or terms of x. Therefore their coefficient of x is nothing but 0. Their elements are 2, 1, 0. Similarly, coefficients of y, 1 minus 2, 1, 1 minus 2, 3, and coefficient of z, 1 minus 1 minus 5, 1 minus 1 minus 5. These are the elements of the matrix A. If their coefficients of x are 2, 1, 0, 0 means the third equations does not containing in terms of x, therefore their coefficient is nothing but 0. Coefficient of y are 1 minus 2, 3, and z is nothing but 1 minus 1 minus 5. Then capital X is denoted for some elements of their variables, and B is represented for constants of the given equation, 1, 3 by 2 and 9. So then first we will find determinant of A. 2 is an elements of first row, first column. These are get neglected and remaining are get cross multiply, 10 plus 3. Then minus 1. Minus 1 is an element of first row, second column, and these are get neglected. Remaining are minus 5, minus 0. And third element is plus 1. 1 is an element of first row, third column. These are get neglected. Remaining is 3 minus 0. That is 10 plus 3 is 13. 13 into 2 is 26. Minus 5 minus 0 is minus 5. Minus into minus is plus 5. 3 minus 0 is 3. 3 into 1 is 3. So 26 plus 3 is 31. 31 plus 3 is 34. Again it is not equal to 0. Then we will find adjoint of each elements of the matrix A. A11. A11 is an elements of first row, first column. These are get neglected. Remaining are get cross multiply, and it's multiplied by plus. That is 10 plus 3. 10 plus 3 is nothing but 13. A12, it's multiplied by minus, and it's an elements of first row, second column, and these are get neglected. Remaining are minus 5, minus 0. That is minus into minus is plus 5. So A13, it's multiplied by plus, and it's an elements of first row, third column, and these are get neglected. Remaining are 3 minus half 0, it will be equal to plus 3. The next element is A21. A21 is multiplied by minus, and it's an elements of second row, first column, and these are get neglected. Remaining are get cross multiply, minus 5, minus 3. So minus 5 minus 3 is minus 8. Minus into minus is plus 8. Then A22. A22 is multiplied by plus, and it's an elements of second row, second column, and these are get neglected. Remaining are get cross multiply, minus 10, minus 0. It will be equal to minus 10. A23, it's multiplied by plus, and it's an elements of second row, third column, and these are get neglected. Remaining are 6 minus 0. It will be equal to minus 6. Then third row A31. A31 is multiplied by plus, and it's an elements of third row, first column, and these are get neglected. Remaining are minus 1 plus 2. Minus 1 plus 2. It will be equal to 1. A32, it's multiplied by minus, and it's an elements of third row, second column, and these are get neglected. Remaining are get cross multiply, minus 2, minus 1. So minus 2 minus 1 is minus 3, minus into minus is plus 3. Then last element is A33. It's an elements of third row, third column, and these are get neglected. Remaining are get cross multiply, minus 4, minus 1. So minus 4 minus 1 is minus 5. Therefore, adjoint of A is nothing but transpose of the cofactor. Now elements of the first row 13, 5, 3. Elements of second row 8, minus 10, minus 6. And in the third row 1, 3, minus 5. After the transpose of these elements can be written as 13, 8, 1, 5, minus 10, 3, 3, minus 6, minus 5. These are will be called as adjoint of the matrices. After then, by using the definition of A inverse. Now A inverse is defined by 1 over determinant of A into adjoint of A. That is 1 divided by determinant of A is nothing but 34. So 1 divided by 34 into adjoint is 13, 8, 1, 5, minus 10, 3, 3, minus 6, minus 5. So next we'll by using the condition of X, where X is nothing but A inverse into B. X is equal to A inverse into B, where A inverse is 1 divided by 34 of 13, 8, 1, 5, minus 10, 3, 3, minus 6, minus 5 into elements of B. B is nothing but 1, 3 by 2, 9. So after then we will get multiply the corresponding elements of rows and then column. Now 1 divided by 34 of 1 over 34 of first row first column. 13 into 1 is 13 plus 8 into 3 by 2. So where 8 into 3 by 2 is nothing but 2 ones are 2, 4s are 8 is get cancelled, 4 into 3 is 12 plus 9 into 1. Similarly, second row first column 5 into 1 is 5 plus into minus is minus 10 into 3 by 2. Again 2 ones are 2 5s are 10 is get cancelled, 5 into 3 is 15 plus 3 into 9. Then third row first column 3 into 1 is 3 plus into minus is minus 6 into 3 by 2. Again 2 ones are 2 3s are 6s get cancelled, 3 3s are 9. Again plus into minus is minus 5 into 9 is 45. So get adding their corresponding elements. 13 plus 12, 25. 25 plus 9, 34. 5 minus 15 is minus 10. So minus 10 plus 27. 17. 3 minus 9 is minus 6. So minus 6 minus 45 minus 51. So get equating there all the elements of the column matrix. 34 by 34 is 1. 17 divided by 34, 51 divided by 34. These are the values of X, but capital X is denoted by small x, y, z. X, y, z. Then equating with the corresponding elements, therefore the values of X is equal to 1. Then the values of Y is equal to 17 divided by 34. Otherwise 17 ones are 17 2s, it can be written as 1 divided by 2. And values of Z is nothing but minus 51 divided by 34. So it's also get cancelled by using 17s are. 17 2s are 17 3s are, that is minus 3 divided by 2. Therefore the values of X is equal to 1. y is equal to 1 by 2 and z is equal to minus 3 by 2. These are called as solutions of that given equations. Next one, x minus y plus 2z equal to 7, 3x plus 4y minus 5z is equal to minus 5, 2x minus y plus 3z is equal to 12. Now let A is equal to elements of first column 1, 3, 2. Elements of second column minus 1, 4, minus 1. Elements of third column 2, minus 5, 3. Then it's another one of the matrix for x, where x is nothing but set of variables in the column form. X, y, z are represented in the column form. And B is another one of the matrix. It contains some constants or the given equations. 7, minus 5, 12 are represented in the column form. Then we'll find determinant of A. So 1 is an elements of first row, first column, and these are get neglected. Remaining are 12 minus into minus is plus 5, plus into minus is minus. Then 12 minus 5 is nothing but 7. Sorry, continue. Minus into minus is plus. So 1 is an elements of first row, second column, and these are get neglected. Remaining are 3 into 3 is 9, minus 5 into 2 is 10, that is minus into minus is plus 10. Plus 2 is an elements of first row, third column. These are get neglected. Remaining are minus 3, minus 8. So 12 minus 5 is 7. 7 into 1 is 7. 9 plus 10 is 19. Minus 3 minus 8 is minus 11. Minus 11 into plus 2 is minus 22. So 19 plus 7 is 26. 26 minus 22 is equal to 4. It's not equal to C. That is the values of the determinant of A. Then A11. A11 is adjoint of cofactors of first element, and it's multiplied by plus. And it's an elements of first row, first column. These are get neglected. Remaining are 12 minus 5. Then A12. A12 is an element of first row, second column, and it's multiplied by minus. And these elements are get neglected. Remaining are 9 plus 10. A13, it's multiplied by plus. And it's an elements of first row, third column. These are get neglected. Remaining are get cross multiply. Minus 3, minus 8. So minus 3 minus 8 is minus 11. Next we'll A21. A21 is multiplied by minus, and it's an element of second row, first column. That is minus 3 plus 2. Minus 3 plus 2. It's minus 1. Minus into minus is plus 1. A22. A22 is multiplied by plus, and it's an elements of second row, second column. These are get neglected. Remaining are 1 into 3 is 3. 2 into 2 is 4. 3 minus 4. 3 minus 4 is minus 1. A23 is multiplied by minus, and it's an elements of second row, third column, and these are get neglected. Remaining are minus 1 plus 2. So minus 1 plus 2 is 1. 1 into minus is minus. The next element is A31. A31 is multiplied by plus, and it's an elements of third row, first column. So minus into minus is plus 5 minus 8. 5 minus 8. It will be equal to minus 3. A32. It's an element, it's multiplied by minus, and it's an elements of third row, second column. And these are get neglected. Remaining are get cross multiply. Minus 5 minus 6. Minus 5 minus 6. So minus into minus 5 minus 6 is minus 11. Minus into minus is plus 11. Then A33 is multiplied by plus, and it's an elements of last row and last column. Again these elements are get neglected. Remaining are 4 plus 3. It will be equal to 7. Therefore adjoint of A equals transpose of the cofactor, then elements of the first row 7 minus 19 minus 11. In second row 1 minus 1 minus 1. Third row minus 3, 11 and 7. After transposition it can be written as 7, 1 minus 3 minus 19 minus 1, 11 minus 11 minus 1, 7. These are will be called as adjoint. Then A inverse is nothing but 1 over determinant of A into adjoint of A. That is 1 over. Determinant of A is nothing but 4. 1 divided by 4 into adjoint is 7, 1 minus 3 minus 19 minus 1, 11 minus 11 minus 1, 7. These are in the elements of A inverse. So after then by using the solution where x is nothing but A inverse into B. X is equal to A inverse into B, where A inverse is 1 divided by 4 of 7, 1 minus 3 minus 19 minus 1, 11 minus 11 minus 1, 7 into elements of B. 7 minus 5, 12. It's multiplied with the corresponding elements of rows and then column. In first row, first column. So 7 into 7. So 1 by 4 of 7 into 7 is 49. 1 into minus 5 is minus 5. Plus into minus is minus. 12 into 3 is 36. Second row 19 into 7. Minus 133. Minus into minus is plus 5. Plus 11 into 12. 132. So 11 into 7 is minus 77. Minus into minus is plus 5 plus. So 12 into 7. So that is 1 divided by 4 of 49 minus 5 minus 36 is 8. Minus 133 plus 132 is minus 1. Minus 1 plus 5 is 4. Minus 77. 84 minus 77 plus 5 is 12. So after that get dividing by 4. 8 by 4 is 2. 4 by 4 is 1. 12 by 4 is 3. These are the value of x. But x is nothing but small x, y, z. Comparing the coefficients of corresponding elements of these two matrices, then the values of x is equal to 2, y is equal to 1 and z is equal to 3. Now these are will be called as solutions of the equations. Next one. 3x minus 2y plus 3z equal to 8. 2x plus y minus z equal to 1. 4x minus 3y plus 2z is equal to 4. Let a is equal to coefficients of x are 3, 2, 4. Coefficient of y minus 2, 1, minus 3. Coefficient of z 3, minus 1, 2. Then x is nothing but x, y, z. And constants are b is nothing but 8, 1, 4. Now first we will find determinant of A. 3 of. 3 is an elements of first row, first column. These are get cross multiply. 2 minus, minus into minus is plus 3. Next element is minus of minus 2. 2 is an element of first row, second column. These are get neglected. Remaining are 4. Minus of minus is plus 4. Plus 3 of. 3 is an element of first row, third column, and these are get neglected. Remaining are minus 6, minus 4. Then 2 minus 3 is minus 1. Minus 1 into 3 is minus 3. 4 plus 4 is 8. 8 2s are 16. Minus 6 minus 4 is minus 10. Minus 10 into 3 is minus 30. So minus 30 plus 16 is minus 14. Minus 14 minus 3 is minus 17. Again it will be not equal to 0. Then A11. It's an elements of first row, first column, and it's multiplied by plus. And these elements are get neglected. Remainings are 2 minus 3. It will be equal to minus 1. A12. It's multiplied by minus, and it's an elements of first row, second column, and these are get neglected. Remainings are 4 plus 4 equals 8 into minus is minus 8. Then A13, it's an elements of first row, third column, and these are get neglected. Remainings are minus 6 minus 4 is minus 10. Then A21. A21 is multiplied by minus, and it's an elements of second row, first column, and these are get neglected. Remainings are minus 4 plus 9 equals 5 into minus is minus 5. Then A22, it's multiplied by plus, and it's an elements of second row, second column, and these are get neglected. That is 6 minus 12. 6 minus 12 is minus 6. A23, it's multiplied by minus, and it's an elements of second row, third column, and these are get neglected. That is minus 9 plus 8. Is minus 1, minus into minus is plus 1. Then A31, it's multiplied by plus, and it's an elements of third row, first column. So 2 minus 3. 2 minus 3 is minus 1. A32, it's multiplied by minus, and it's an elements of third row, second column, and these are get neglected. That is minus 3 minus 6. So minus 3 minus 6 is minus 9. Minus into minus is plus 9. Then A33, it's multiplied by plus, and it's an elements of third row, third column, and these are get neglected. Remainings are 3 plus 4 equal to 7. Therefore, adjoint of A. Now the elements of adjoint of A can be written as in the form of column wise. It's not particularly represented in cofactors and transpose. So cofactor na mention ಮಾಡಿ transpose ಮಾಡೋದ್ರ ಬದಲು ಡೈರೆಕ್ಟ್ ಆಗಿ adjoint elements ನ represent ಮಾಡಬಹುದು. But if these elements are represented in the form of column wise, so according to the definition of cofactor, so elements of the first row is represented in first row, second row are represented in second row, and third row are represented in the third row. After transpose of the cofactor is called as adjoint. But transpose means interchanging the rows and column means elements of rows are always represented in the form of column. Therefore, suppose we will write the elements of adjoint without mention their cofactor. What are these elements are represented in the column wise? Minus 1, minus 8, minus 10. Elements of second row, minus 5, minus 6, plus 1. These are the cofactor of second row, but after transpose these are represented in the second column. And third row, minus 1, 9, 7. These are in the elements of third column. These are will be called as adjoint of A without representing the cofactor. So after then, by using the A inverse. A inverse is nothing but 1 over determinant of A into adjoint of A. That is 1 divided by determinant of A is minus 17. It can be written as minus 1 divided by 17 into adjoints are minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1, 17. These are will be called as inverse of that matrix. So after then, by using the solution where x is nothing but A inverse into B. Elements of A inverse are minus 1 divided by 17 into minus 1, minus 5, minus 1, minus 8, minus 6, 9, minus 10, 1, 7 into elements of B. B are nothing but 8, 1, 4. B is 8, 1, 4. So get multiplied their corresponding elements of row and column. Minus 1 divided by 17 of first row, first column. Minus 1 into 8 is minus 8. Minus 5 into 1 is minus 5. Minus 1 into 4 is minus 4. Again, second row, first column. Minus 8 into 8 is minus 64. Minus 6 into 1 is minus 6. Plus 9 into 4. Then third row, first column. Minus 10 into 8 is minus 80. Plus 1 into 1 is 1. Plus 7 into 4. Get adding or subtracting their corresponding element. Minus 8 minus 5 is minus 13. Minus 13 minus 4 is minus 17. Minus 64, otherwise 36 minus 6 is 30. 30 minus 64 is minus 34. Minus 80 plus 28 is 62. 52 minus 52 plus 1 is minus 51. Minus 80 plus 28 is minus 52. Minus 52 plus 1 is minus 51. So after then these elements are get multiplied by minus 1 divided by 7. Minus into minus is plus, 17 by 17 is 1. Again minus into minus is plus, 34 by 17 is 2. Minus into minus is plus, 51 by 17 is nothing but 3. Now these are the values of x, y, z. So equating their corresponding elements, therefore the values of x is equal to 1, y is equal to 2 and z is equal to 3. These are will be called as solutions of that equations. Next one is one of the statement problem. First we will read the statements. The sum of three numbers is 6. Sum of three numbers is 6. If we multiply third number by 3 and add the second number to it, we get 11. That is the second condition. By adding first and third number, we get double of the second numbers. That is the third condition. Represent it algebraically and find the numbers by using in the matrix method. So we will already know that what about the solutions of the matrix method means the given equations are always represented in the form of linear form. Ax plus by plus cz is equal to sum of their constant d. But in these cases, the equations are represented in the form of statements. Therefore, first we will have to convert the given statements in their algebraic form. So, first we will consider the solutions of variables x, y and z. First, second and third variables are represented or choosing x, y and z respectively. Means first value, first number is denoted by x, second number is denoted by y, third number is denoted for z. The number first, second and third are represented by using the variables x, y and z respectively. So by using these condition, how to can we represent the above statements are in their algebraic form. So first we will read the given statements. Now, first statement is the sum of three numbers is 6. Now, what are numbers are will be considered in the three numbers? These are x, y, z. X, y, z are the some three numbers, but in particularly x is called the first number, y is the second number and z is the third number. Therefore, first equation of this statement says sum of three numbers is nothing but 6. Therefore, it can be written as x plus y plus z is equal to 6. That is one of the equation. Then the next condition, if we multiply third number by 3, if you multiply third number by 3, now which one will be called as third number? So I will be choosing for the 3 numbers x, y, z are in the respective form of first, second and then third. Therefore the third number is nothing but z. So if we multiply third number by 3 means 3 get multiplied with z, that is 3z, and add second number to it. Now second number is nothing but y. So it get adding the second number to it. ಅದರ ಜೊತೆಗೆ ಸೆಕೆಂಡ್ ನಂಬರ್ನ ಆ್ಯಡ್ ಮಾಡಿ, ದೆನ್ ವಿ ಗೆಟ್ 11. ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು 11. That is another one of the equation. Similarly, now the third equation is by adding first and third number. By adding first and third number. What are first and third number? X and z. These are get adding with each other. Adding first and third number, we get double of the second number. We get double of the second number. Now the second number is nothing but y. Double of that number is nothing but 2y. Double of the second number. These are the some equations are represented in the above statement. Now first condition is sum of 3 numbers is nothing but 6. Therefore x plus y plus z is equal to 6. Second condition is multiply third number by 3. Third number means z, it's multiplied by 3 is nothing but 3z, and adding with the second number. That 3z is adding with second number is nothing but y. Then we get 11 is equal to 11. And the third equation is by adding first and third number. First and third numbers are nothing but x and z. These two are get adding with each other, and it's double of the second number. It will be equal to double of the second number is nothing but 2y. So these are the representations of the equations are in algebraic form. After then we'll solving these equations by using in the previous method. But in the third equation which also can be written as these two will be represented in the same form. First and second equations are already represented in the form of ax plus by plus cz equal to d. But in the third equations in terms of y is represented in the another side. Therefore we'll get alterating that equations. It also can be written as x minus 2y plus z. X minus 2y plus z is equal to 0. That is the correct form of that equation. That is generally in the form of ax plus by plus cz is equal to d. So after then solving this equation by using the matrix method. So matrix method means solutions are represented in the form of inverse of a matrices. Therefore first we'll write the elements of the matrix C, where A is nothing but what about the coefficient of x in all the 3 equations. In the first equation x is nothing but 1 times of x, but in the second equation is nothing but 0 times of x, and third equation is nothing but 1 times of. Therefore the elements of A are 1, 0, 1. It's an elements of first column. In the second column coefficient of y is 1, second equation is also 1, but third equation is minus 2. That is 1, 1, minus 2. And in z 1, 3, 1. X is nothing but x, y, z are in their column matrix, and B is nothing but some of their elements of the constant on the given equation 6, 11, and last one is nothing but 0. 6, 11, 0. Then solving that equation, determinant of A is nothing but 1 half. Left diagonal is 1, minus half minus is plus 6. Now second element is minus 1 half. Again 1 is an element of first row second column, and these are get neglected. Remaining are 0 minus 3 plus 1 half. Again 1 is an element of first row third column. Remaining are get cross multiply. 0 minus 1. That is 1 plus 6 is 7. Minus into minus is plus 3. 1 into minus 1 is minus 3. 7 plus 3 is 10. 10 minus 9 is, 10 minus 1 is 9. Again it's not equal to 0. So after then we'll find the adjoint of the elements of a given matrices. Now A11. So A11 is an element of first row first column, and it's multiplied by plus. So these elements are get neglected. Remainings are 1 plus 6. It will be equal to 7. A12, it's multiplied by minus, and it's an elements of first row second column. These are get neglected. Remainings are 0 minus 3. 0 minus 3 is minus 3. Minus into minus is plus 3. A13. it's multiplied by plus. And it's an elements of first row, third column. These are get neglected. Remaining are 0 minus 1. It's nothing but minus 1. Then A21. It's multiplied by minus. It's an elements of second row, first column. These are get neglected. Remaining are 1 plus 2 is minus 3. A22. It's an elements of second row, second column. And again these are get neglected. Remaining are 1 minus 1. So 1 minus 1 is 0. Then A23. It's multiplied by minus. And it's an element of second row, third column. Remaining are minus 2, minus 1. So minus 2 minus 1 is minus 3. Minus into minus is plus 3. Then A31. A31 it's multiplied by plus. And it's an elements of third row, first column. And these are get neglected. That is 3 minus 1. It will be equal to 2. A32 is multiplied by minus. And it's an elements of third row, second column. Remaining are 3 minus 0. It will be equal to minus 3. A33 is multiplied by plus. And it's an elements of third row, third column. These are get neglected. That is 1 minus 0. It will be equal to 1. Therefore, adjoint of A. Now, what are the elements of the first row are represented in the first column? 7, 3, minus 1. So, but if these are the elements of first row in terms of cofactor, but directly can be represented in the elements of adjoint. What are the elements of the first row are represented in the first column. And elements of second row can be written as in the form of second column. Minus 3, 0, 3. And elements of third row, 2, minus 3, 1. So, these are will be called as adjoint of A. Therefore, A inverse is nothing but 1 over determinant of A into adjoint of A, where determinant of A is nothing but 9. 1 divided by 9 into adjoint is 7 minus 3, 2, 3, 0, minus 3, 1, 3, 1. These are will be inverse of that matrices. So, after then by using the solutions of X, where X is nothing but A inverse into B, where A inverse is 1 by 9 of 7 minus 3, 2, 3, 0, minus 3, 1, 3, 1 into B is nothing but 6, 11, 0. B is nothing but 6, 11, 0. So, after get multiply corresponding elements of rows and then column. Then 1 by 9 of first row, first column, 7 into 6. Minus 3 into 11 plus 2 into 0. Again second row, second column, 6 into 3, 0 into 11, again 0 into 3. Third row, first column, 6 into 1, 3 into 11 plus 1 into 0. That is 1 divided by 9 of 42 minus 33 is 9, plus 18 plus 0 is 18, 6 plus 33 is 39. We'll see. So, please make it your correction. Adjoint of A is nothing but 7, 3, minus 1. Elements of adjoints are 7, 3, minus 1. Therefore, 7, 3, minus 1, minus 1. So, minus 1 into 6 is minus 6. So, minus 6 plus 33. So, minus 1 into 6 is minus 6. So, 11 into 3 is 33. That is nothing but 27. Therefore, 9 by 9 is 1. 18 by 9 is 2. 27 by 9 is 3. These are the values of x, y, z. Therefore, x is equal to 1, y is equal to 2, and z is equal to 3. These are the some 3 numbers are according to the given statement. So first condition will already satisfy the given equation. Sum of that numbers is nothing but 6. That is 1 plus 2 plus 3 is nothing but 6. Therefore the first conditions are will be satisfied. Now the next condition, multiply third number by 3 and it's adding second number, means third number is nothing but z. Z is multiplied by 3 is 3 into 3 is 9 and adding the second number is 2. 9 plus 2 is 11. So 11 is the right hand side of the, means constant of the second equation. Therefore the second equation is also satisfied. And the third equation is by adding first number and third number. First and third means 1 plus 3. 1 plus 3 is nothing but 4. It is double of the second number. Double of the second number is 2 into 2 is also 4. Therefore 4 is equal to 4. Therefore these values are always satisfy the given set of equations.